Hi, welcome to my video on double angle formula for cosine number 3, proving identities number 1. We got 2 videos on proving identities. Prove 1 plus cos 2 theta over cot theta equals sine theta. And as in all identities, we have a left side, which is 1 plus cos 2 theta over cot theta, and we have a right side which is sine 2 theta. Looks like the left side is the more complicated one, so we'll take the left side and change it to sine 2 theta. But sine 2 theta is 2 sine theta cos theta. So we have to change. Cos 2 theta has to go, but what do we change it to? Do we change it to cos squared minus sine squared, or 2 cos squared minus 1, or negative 2 sine squared plus 1? Well, part of a clue to it would be, let's look at cot. Cot is cos theta over sine theta. And so we have a 1 plus, so we change it to, and if you look at it, the sine that's on the bottom here will, when we multiply by the reciprocal, will go to the numerator, so we got sine here. So it looks like we have to eliminate the cos. So let's go with 2 cos squared theta minus 1 for cos 2 theta. When we do that, the 1's cancel out, so we get 2 cos squared theta over cos theta sine theta, and that becomes 2 cos squared theta times the reciprocal, which is sine theta over cos theta, and we got a cos squared and a cos, so they cancel out, so we get 2 cos theta sine theta, which is 2 sine theta cos theta, and that becomes sine 2 theta. And since the left side equals the right side, it is an identity. I haven't spelled identity often enough to know, but it's just an error, identity. Now let's do number 2. So we had to prove that 2 cos squared of pi over 4 minus theta over 2 equals sine theta plus 1. So again, we have a left side, which is 2 cos squared pi over 4 theta over 2. And we have a right side, which is sine theta plus 1. So notice we have a sign here. So we change the cos squared to, let's see, we have a 2, we need a plus 1. So how are we going to do it? Well, a little trick that I use is that we make it negative 1 plus 1. Negative 1 plus 1 is the same as 0, but I need the negative 1 in order to change 2 cos squared pi over 4 theta over 2, and I change it to, that becomes cos 2 on the angle, that becomes plus 1. So this is, if this was alpha here, so this is an alpha here, so the cos squared of alpha minus 1 is the cos of 2 times alpha. And that becomes, if we have a change, so we multiply by 2, we get cos. 2 times pi over 4 becomes pi over 2. 2 times theta over 2 becomes theta. The 2's cancel out. Plus 1, so we have our plus 1 here. So this must be cos, and this is the cofunction. So the cos of 90 minus theta is the sine of theta. One of the properties we did in earlier videos. And that's on trig 1. So the left side equals the right side. So since the left side equals the right side, it is an, see if I can, it is an identity. Again, you gotta, I made these up so they're a little bit more difficult, and you had to see some pattern and lock into that pattern. Here we go, one more. We have to prove this identity. Again, we have a left side, which is sine theta over 2 cos theta over 2 squared, and the right side is 1 plus sine theta. So we got a square, so it looks like we're going to have to work the left side first to come up here and to get the 1 plus sine. So we square this, so that's sine theta plus cos theta over 2 times sine theta over 2 cos theta over 2. And we'll multiply this by FOIL. So the first is these two. So that becomes sine squared of theta over 2. Add on sine theta over 2 times cos theta over 2 becomes sine theta over 2 cos theta over 2. So that's the first to give me this term. Outside is these two. Inside is these two. So that's cos theta over 2 sine theta over 2. And last is cos theta over 2 cos theta over 2. And we have to simplify this. Oh, that's when I wrote down the two of these twice, but really I didn't need to do that. Make that a cos squared. So notice I have cos squared theta over 2 sine squared theta over 2. So let's group the two of those. Okay, and right here we have, this is right down to two of these, so that's the sine theta over 2 cos theta over 2, and this, I'm going to rearrange this, sine theta over 2 cos theta over 2, so I rearrange this because multiplication is commutative, so I can switch these around, and you'll notice we have, now we have sine squared cos squared of the same angle, so that's a 1. And right here, these two are now the same, so it's 2 lengths, so I get 2 of them, so that's 2 sine theta over 2 cos theta over 2. And notice that 2, the sine theta over 2 cos theta over 2 is the same as the sine, the double angle of theta over 2, so that's alpha. So 2 sine alpha cos alpha would be the sine of 2 alpha. So alpha is theta over 2. So they can, 2's cancel out, so I get the sine theta. And again, we have the left side, since the left side equals the right side, it is an identity. And I spelled it right this time too. And that's 3 proofs on identities dealing with the double angle formulas, etc. sine 2 theta, cos 2 theta. And again, if you like my video, click on the like button, click on the subscribe button. If you wish, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Hope the video was of some help to you. Thank you for viewing the video. Bye-bye.